Hi friends, let's continue our journey into the process management of operating system. Under this, let us see. We began the operating system with something called MS-DOS, disk operating system, which was designed by Microsoft, which was very famous, quite famous, MS-DOS. So in general, it was a disk operating system which was meant to process one process at any given time. Therefore, it was a single tasking operating system, and anytime only one active program used to run, and the entire CPU was devoted to one process, and the memory was sufficient to accommodate only one process. So there was no chance of accommodating more than one process. During those days, the processor was like a 8086, which was a 16-bit processor having 20 bits of address lines, which maximum could work with 1 megabyte of memory. Of this 1 megabyte memory, 640 kilobyte was reserved for the disk operating system or the operating system, and the remaining 360 kilobyte of memory was available for the user process. In that, only one process could be accommodated. So if we want to run one process, so we just load that process onto the main memory, run it, and once that is done, then want to run another one, then it has to replace the first process from the memory, and the second one should get into its place. So that was the day when we were working with a single process any given time. But later, with time, the technology developed, VLSI came in, so 801, 86, 286, 386, and Pentium and all that went on improving, and with that the memory on board went on growing exponentially, and with this we could accommodate more than one process at any given time. That means we can load more than one program from the backend onto the main memory at any given time. But since there is only one processor available, so any one of these processes can be made active and all others should be inactive. And this type of working is what we call multitasking. So the multitasking operating systems can run multiple processes simultaneously. That means it can have multiple processes simultaneously on the memory, but anytime only one process will be active, only one process will get the CPU time, all others should be waiting. So the examples were Linux, Windows, Mac OS and all that. So here the CPU is allotted to any of these processes one after other, or as per the user's requirement, and the CPU time is divided between these processes that are active. We see more detail what mean by active process, what you mean by waiting process and all that. And then we have interrupts. So the interrupts were very limited in case of single tasking operating system, but when it comes to multitasking, we must handle multiple IOs, multiple system and user interrupts were supposed to handle. So we need a little more complicated operating system for doing so. The memory, all the memory was allocated to one process in case of single tasking operating system, whereas in multitasking operating system, each process will have its own memory segment from the main memory, and the CPU is allotted from time to time. So that's a difference between single tasking and multitasking. So there is nothing much to talk about single tasking. So from now onwards we will be working only with the multitasking at its base. So whatever we speak about operating system, it is the minimum facility we are providing is multitasking. So no more single tasking activity, it is multitasking, and then we extend our functionalities beyond that. So that's where we begin our journey with a multitasking. So that's all for this session. If you find this session of any use, please don't forget to like, subscribe the channel, and please share with your friends, and have anything to say, please do comment. So that's it for now. Thank you.